Hello everyone, so this is Monica here. So as a part of my data science internship program at the Sparks Foundation, this is my second project. Technically speaking, it is task 4 of the data science internship program, and it is called stock market prediction using numerical and textual analysis. So the data sets I have used here is stock prices from Yahoo Finance website and news headlines from this website. So I have pasted both the links here if anybody wants to use it. So moving forward, first of all, I have imported all the libraries which I need for the prediction. So such as maths, pandas, numpy, then matplotlibs and seaborn for plotting, then keras for model building, nltk for sentiment analysis, and sklearn of course for modeling. First of all, I have read both the data sets into my pandas data frame, and then I've displayed both the data sets so that we can know how the data sets looks like and what are the columns which we are dealing with. So next, and I have done feature engineering, such as so I have found the number of records in the stock price and the number of records in the stock headlines data sets. Then I have checked out for null values if there are any null values in both of the data sets. So which is not the case here. So as you can see here, everything is written as false. That means there is no null values in the data sets. So next, I have done some feature engineering, which is dropping of duplicates, and then I have also made the date column as the index column, which is suitable for data like this, which is time series data. So same for the news headlines here. So I have made published date as the index column here as well. Next, I have combined both these data sets because I will be dealing with both these data sets for my prediction. Next, I have calculated sentiment scores here. So first of all, I have made empty columns such as compound, negative, neutral, and positive. So I will be calculating sentiment scores for all of these columns using sentiment intensity analyzer from NLTK package. So as you can see, I have calculated all the scores such as compound, negative, neutral, and positive. So here I am finalizing the whole stock data and rearranging the columns as I want them to be. So first of all, I have dropped the column headline text, and next I have filtered the columns which I really need for this prediction to work, such as close, compound, negative, neutral, positive, open, high, low, and volume. So that was my data, finalized data, and then I'm writing my whole data to my disk so that I can even need this data later on. So instead of like spending time on again reloading the data and calculating all of these, so I have just written the finalized data to my disk, and if at any further points I need them, then I can just read the data and do my analysis on it. So likewise, I have again read the whole stock data, and then made certain adjustments, such as I have fixed the date column as the index column here. Also, then again, I have done feature engineering on the whole stock data, which is finding out the shape of the data, which is number of columns and number of rows, finding out if there are null values, which they aren't, and finding out some descriptive statistics of all the columns, and also some information on the columns of the data set. Next, I have done some ETA on the stock data, which is the final stock data. So here I have plotted out the close price as per date. So you can see here how the close price is increasing as per date. Then I have calculated the rolling mean average for a period of 7 days. So as you can see here, the first 6 rows here are null values. So they all have null values. So as it is a 7-day rolling mean average, so obviously the first 6 rows will have null values, and the average will be calculated for the 7th day onwards. So that was that. And next, I have tried to plot the close price and the rolling mean average over a period of 30 days on the same plot. So as you can see, the orange line represents the rolling mean average over a period of 30 days, and the blue line represents the actual close price. So the average and the actual close price is does not have that much difference. So yeah, that's my final stock data. So next, I have done some data preparation for modeling. So I have calculated what should will be the length of my training data and my test data here. So next I have filtered some data for individual columns, and the reason I have done it for individual columns is because I have to calculate my shifted close price and my shifted compound. So this is basically I'm doing the time step here, and the time step I've used here is -1. Then I'm attaching those shifted columns to my main data frame. So my main data frame now has columns like close price shifted, compound shifted, volume, open price, high and low. So this will be the data set which I'll be using, which I'll be feeding into my model. So next I will be setting my target variable and my feature data set. So my target variable here is not close price but close price shifted. So through this I will be predicting what will be the close price for my next day. So that is that. And then I have defined my feature data set separately as X. So then I will be scaling my target variable and the feature data set. So since we're using LSTM here to predict the stock prices, so it is a time series data. It is important to understand that LSTM can be very sensitive to the scale of the data, and right now if you observe the data very carefully, it is present in very different scales. So therefore it is very important to rescale the data so that the range of the data is same for almost all records. So for here I have used a feature range of -1 to 1. So all my data will be in between -1 to 1. So I have used different scalars. So by different scalars, I mean I'm using the same min-max scalar for my both target and my feature data set, but I'm instantiating it using different names for my separately for my feature data set and for my target variable. For example, here I have used the name scalar X for my feature dataset and the name scalar Y for my target variable. This will be very useful later on while unscaling my target variable and my feature dataset as well. So next I will be dividing my data set into training and test data set. So here for normally for any other data set we use a train test split from sklearn package to divide my data set into training and test. But for time series data like these stock prices, it is dependent on date, and the data set is divided into train and test data set in a very different way. So this is this is the way I've actually used here to divide it into my X train, X test, Y train and Y test. So I have not actually used some package from sklearn, but I have done it or divided it into my different data sets using indices. So yeah, so that's how I divide my data set into training and test. Then I have also reshaped my feature data set into 3 dimensions, because in LSTM we are required to reshape data. So here here's a way that I have done it. Next, I wanted to show you how I have done my setted my model architecture. So first of all, I have set a random seed of 2016 to achieve consistent results every time I execute this program. Then I have added 3 LSTM layers followed by dropout layers as well. Also, I have used activation using Tanich. So this is my model architecture which I have defined, but you can use you can try to change here and there. So suppose you can not use dropout, or you cannot use activation if you want to, but for my model architecture I found that putting activation and dropout works give me the highest accuracy as possible. So that's how this is my model architecture. And then I have compiled my model using MSE loss. MSE stands for mean square error here, and using Adam optimizer, after which I have fitted the model into my training data set, which is X train and Y train here. The number of epochs I have used here is 10 epochs, and the batch size is 8. So as you can see here, the validation loss is decreasing with every epoch, and that is what exactly we want here. Next, I'm saving my model to disk in the form of JSON and H5 files. It can be used later on if I want to, if I have the same data and I want to, if I have a similar data set and I want to predict it. So instead of going through all the trouble here, I just have a model, and I will recall this model and can do my prediction using my already built model. Next, I have done predictions on unseen data. For that, I have used model.predict, and my unseen data is XTEST, obviously. And as we know that that all the model building and the predictions which we have done is on scaled data, so the predictions which we got is not the actual predictions, and therefore we need to unscale them to get the actual predictions of the data. So that is why I have used the object scalar underscore y here and the function inverse transform. So that is the predictions, and then we will evaluate the model using model.evaluate and root mean squared error. So model.evaluate will give me the loss of the train data and the test data. So here the train loss is 0.002 and the test loss is 0.001, which is very less, and which means that that we are going in the right direction. Also, I have calculated the root mean squared error manually as well as using sklearn.metrics package, and I have got the same value using both the methods, which is 50. Next, I have plotted the predictions against unseen data. For that, I have first unscaled the data which is required here. So I have first unscaled the x test using scalar underscore x, and I have unscaled the y data set using scalar underscore y. So yeah, so first unscaling the data and then I have plotted it. So if you see the plot, the orange line is the actual testing closing price, and the blue line is the predicted closed price. So we can see here that how well it has fitted the model, and through this we can know that the accuracy is good for this model, and also the loss is very low. So I've included references for this whole project. Last but not the least, I would like to thank Sparks Foundation for giving this opportunity to work on this project. This is a very different project which I have not worked before. So also please let me know if you like it, if you like this or not, and I'm also open to any discussions further on. Thank you.